Thanks, Evan. This is really very interesting. I'm enjoying it. And what I want to do is actually talk about some of the new attractive kinds of manufacturing that Stacy Wagner mentioned earlier, particularly as this kind of manufacturing relates to communities and revitalizing communities, communities like Richmond. But the easiest way for me to do that is to basically tell you a little bit of my story. And that starts about 20 years ago when I found myself in the backyard with an electric jigsaw cutting out parts for plywood boats. Boats like this model here that I had a computer model for. In fact, I had perfect computer plans for this. And I needed to cut the plywood out to make the boat in my backyard. And I found myself having to print out sheets of paper, tape them down to the plywood, and then take the saw to try and cut the thing out, even though I had this really precise plan. And it was frustrating. I wasn't doing a very good job of doing it. And I thought, oh, what I need to do is find one of these manufacturing tools that are computer controlled and cut things out along the curve exactly the way you want. And I looked around North Carolina to try and find an old used one. And the best I could do was 50 miles away. A thing that cost $40,000 was marginal with respect to whether it worked or not. And beyond that, it weighed 4 tons. This just wasn't the tool that I envisaged for my garage. And I thought, well, you know, these things, these cutters are nothing more really than a giant plotter, you know, that moves around a cutting tool, a thing called a router. And I thought, oh, I should be able to make one of these for a couple $1,000s. And this is me a year or two later showing off my first Rube Goldberg contraption at a meeting of the local woodworkers association. And believe it or not, the thing worked. And it got me amazingly captivated with the incredible ability to precisely cut and machine and carve that these computer-controlled tools, called CNC tools, were actually capable of doing. And that led to a kit tool that I sold for a while, and eventually to a manufacturing business. We now make a series of computer-controlled cutting tools. They're known as CNC tools, CNC routers. The company is ShopBot. We call our tool ShopBot. And we build these tools in Durham, North Carolina, from start to finish, basically. And my company, ShopBot, itself is a success. It's a success as a small manufacturing operation. There are something like 8,000 ShopBots in factories and small shops around the world, cutting away and making stuff. They're in places like furniture factories, places like aerospace companies where they cut plastic and aluminum, and essentially enhance the productivity of all of these operations. But there's a dark side to the story in the sense of the effect of this enhancement, this improvement in performance that we create in manufacturing, very similar to one described a couple months ago on a 60 Minutes program about the impact of robotics in manufacturing, all about the degree to which the productivity enhancements that robotics and automation produce are wonderful in terms of making our businesses competitive, but at the same time, they're eliminating jobs and they're reducing the level of expertise involved in jobs. And a week, well, it's probably a month or so ago now, I was visiting one of our customers in a nearby town in North Carolina, and a production engineer at this factory said to me, he was proud of this, he said, "Ted, this is really great, you know, that we brought one of your tools in, and I was able to break a man off a tool so that he could now run 3 tools. And you know what? Beyond that, I could now use a low-skilled worker rather than an expert worker. And you know, this was success for his manufacturing operation, but it wasn't, I mean, of course I want to sell the tools, but there's something about it that also creates a concern about where we're going with manufacturing. Yes, we get productivity increases, but we're reducing the number of people employed, and we're reducing the skill level to a large degree of those who are doing some of these jobs. I'm sure you're all familiar with the degree to which over the last 50 years we've gone from a country that employed almost 40% people working in manufacturing to now less than 20%. The easy explanation for a lot of people for that is, oh, you know, we offshored those jobs to China. Those jobs got shipped out to countries where the cost of labor was a lot lower. But the reality is that at least half of those jobs, half of that reduction in our manufacturing workforce is due to the effects of enhancements to productivity, largely due to robotics and automation. Steve Jobs told us that those jobs that went to China, they're not coming back. We may get a few back as lifestyles improve, the living standards improve in China, and the cost of transportation goes up. But those jobs are gone, and so too are the jobs that we've lost to improvements in productivity. It creates a bit of a bleak situation when we think about the contribution that manufacturing is going to make to our communities. But in the midst of all this, we have a growing recognition, I think, almost because we've lost so much technology overseas, that manufacturing, doing it in your country, doing it in your community, is critical to our ability to continue innovating and to continuing being scientific leaders. As humans, we really rely on our ability to manipulate things with our hands, to assemble things, to build things, to put things together, to be creative, to be innovative. In fact, to a large degree, I think you can argue that, the slide comes, making stuff physically is really what our thinking is all about and where the source of our inspiration comes from. So I think that, and a lot of people think, and I've come to recognize this, I believe, that manufacturing is something that it's important for us to do. It's also one of the few activities that's productive and value-adding. And so it's something we want to have around. And it's a kind of activity that, as it creates jobs, creates lots of secondary jobs and lots of spin-off supports and activity as well. So we want to do manufacturing. We want to do it in a way that creates good jobs, and that it's a kind of manufacturing that's agile, forward-looking, and so on. What I'd like to tell you and sort of show to you is the way in which these new digital technologies have another side to them, have a positive side that can create a new kind of manufacturing, a kind of manufacturing that can exist in your communities. And the best way to lay that out for you is to describe it in terms of digital fabrication. Digital fabrication is really the way we make stuff now. We start on the one hand with a digital model. We often involve digital engineering, development, and prototyping systems that eventually lead to a digital production process. All of this is continuously linked by the computer, the digital bits that represent the whole engineering process. This all used to take place in the factory, and it was many divisions of the factory. You had engineers, you had people who worked in the shops, you have machinery. The amazing thing about the new tools and technology that are evolving is that they compress this continuum this ability to make and manufacture stuff into a much smaller space, into a much smaller kind of machine, kind of tool, and kind of process, such that individuals can be involved in the whole process. It's not these tools that I showed you, the ShopBot in the beginning, it's not just about automation. It's a kind of tool that by integrating individuals into this process of digital fabrication really gives unique new capabilities at a level that is appropriate for individuals and small shops. It's not just about production. This whole process of digital fabrication really changes the way we work and we make things. So I'll show you in a real simple piece of furniture here how digital fabrication works. This is a beach chair that, if any of you are old enough to have been in high school wood shop in the 50s, this was actually a standard chair. Kids had to cut on a bandsaw. It was a half semester project because it was so much work to get the curve cut and to individually attach in the right position all of these slats going across the thing. Well, the new tools, these tools for digital fabrication, are capable of such precision in the way they can cut and machine that the whole assembly process, this is one of the sides of those chairs, can be cut out and embedded in the part. These are tenons that are going to fit in that mortise there. Here's an example of them. These are a couple tenons off one of those chairs. They fit perfectly in this thing. These kinds of cuts are things that it's very difficult for any individual to do, even a skilled individual, and particularly to do, say, 20 or 30 of them in exactly the right place, like here. This is a sheet of plywood with two of those chairs on it. But for a digital fabrication tool, it's just as easy to cut a curve. It's just as easy to cut a complex part. It's just as easy to cut a part with engineering embedded in it. It's just as inexpensive. So that these tools are quite empowering with respect to allowing an individual to actually make stuff in ways that they were never able to make things before. The tools work across a wide range of scales. Here's a house going up that was cut using a digital fabrication tool made up of thousands of jigsaw-like pieces that ended up being assembled as a demonstration project in front of the Museum of Modern Art a couple summers ago, illustrating the new ways that digital manufacturing can contribute to making things as big as houses. The same kind of tool, working in a different material, can cut something as small as this teeny little piece of composite material that's intricately locked together. The same kind of tools can machine aluminum, plastic, steel, and embed that same level of precision cutting or machining or carving or whatever that I indicated to you before. And this small size here just foreshadows the degree to which these tools are actually precursors to where we're heading, which is smart materials, smart nanotechnology materials that will self-assemble themselves into someday whatever we need. When we're done with it, they'll unassemble themselves, and so we can use them in something else. I mean, down the road, it's this technology that really will get us to that gold standard of manufacturing that I'm sure you all know, called the Star Trek replicator. It's where we're heading. It will be a while before we're there. The digital fabrication tools that I'm talking about come in at least 3 different types. There are additive digital fab tools. You know those because you've heard a lot about 3D printers lately. They very accurately deposit stuff and can make all sorts of incredible things. There are subtractive tools, like the CNC tools I've been kind of showing you examples from. Laser cutters, plasma cutters, water jet cutters. they work too with a high degree of precision, able to cut parts with, from small to big out of practically any material, and tools for robotic assembly. All of these tools used to be things only available at an enterprise level in a factory, but now you can get high quality parts from this kind of equipment even in small shops anywhere, because the stuff is affordable. Affordable for 1, 2, 3, 4, 10-person operations. It uses digital designs which are portable, shareable, and they can be collaborated over very easily because we're using the internet to communicate. And that means that small conglomerations of fabricators can work together on things and accomplish work that requires interaction of more complex parts. And it's easy to manage because the complexity and engineering can be embedded in those parts at design time. I mentioned the wide scale range of components, and these tools, if we distribute them across our communities, we will be able to work more efficiently because we can work with locally available materials, and we can use these in the place where they're going to be needed. And so we're working in a way that's environmentally aware and environmentally sensitive. So 100 years ago or more, we had in our communities people like blacksmiths, violin makers, and watchmakers. These people used their tools and their skills in ways that allowed them to both serve the needs of the stuff that was needed in the community, as well as doing specialized stuff for the world. The watchmaker to the world, the blacksmith to the community. In both cases, it was the intrinsic motivation of these people that really helped power the growth of towns and countries. But ultimately, as we industrialized, these people couldn't compete because the tools they had were not able to reproduce accurately. They couldn't cut and machine things in ways that allowed them to integrate with factories or to integrate what they were doing with other artisans. They weren't able to compete in a mass production world. They weren't able to connect and collaborate. They didn't have what we would call today reach. But the new manufacturers, new small manufacturers using digital fabrication tools have what these blacksmiths, watchmakers, and violin makers of the past didn't have. They have tools that make life practical in the small shop. They're affordable, they can be loaded with intelligence, and the tools make them competitive because they're efficient, they're small, the operations are small, they're agile, they can happen in your community. They're low capital. It doesn't take much to get one of these small businesses started, and they have access to the world via the internet. That is, they can work to make the stuff you need in communities, or they can work to make stuff that's competitive in the broad world because of the power of the internet that gives them reach. There are two books I should mention that have recently been published. One by Chris Anderson called Makers, and a second book by Lipson and Kerman called Fabricated, that both talk about the way in which these tools provide capability for the small shop on the one hand, but because they're embedded in today's digital technology, allow world access on the other. These tools are described, and digital fabrication is described as a process that basically democratizes the tools of production. And when people say that, what they mean is that they're making these tools available to the guy on the street, to the small-time entrepreneur in your town. Here's a couple of those entrepreneurs, just so you can see what they look like. Philip Fletcher uses digital fabrication to make bookshelves, bookcases. He designs and finishes and does unfinished bookcases and competes locally in his region and town with big box stores. He's not quite as affordable, but he makes stuff that's competitive because it's the way people want it. It fits in their corner of their living room. It's customized in the way they want it done. He's got 6 employees, and together they're able to operate a successful small business doing furniture kind of work. Here's another digital fabber. This guy, Garrett Finney, was a NASA space architect. He designed space stations and things like that, but he wanted to do something for Earth. So he came up with a design for this high-tech, ecologically friendly, he calls it athletic travel trailer. It's built out of composite materials, all cut on a digital fabrication tool by his small factory, his small shop in Texas. It's been featured in Dwell magazine. He's got back orders for like 11 months, I think, and it's just a nifty little thing. The interesting thing is the way in which in these small shops, the technology is kind of self-perpetuating because people get brought in and they get trained. They get an opportunity to understand the equipment, the new equipment that's brought in. It's like this is the kind of place that the on-the-job training happens for these new technologies. Melissa Jones is a Minnesota mother who got excited about digital fabrication and the carving she could do for signs using the exact same kind of equipment that I've been talking to you about. And she developed a thriving local sign business that, because it was on the internet, got noticed by some people in Hollywood, and she now makes stuff for movies as well. It's a pretty interesting way for things to go. Here's another high-tech guy. Sean Martin uses digital fabrication to make snowboards. He uses all sorts of exotic composites and laminates in what he's doing in his small shop in Colorado, and he makes Olympic quality competitive snowboards. His shop could just as easily be making parts for airplanes or spacecraft. And of course, he's marketing to the world. Brooke Davis uses digital fab for her artistic furniture. She's a studio furniture design and furniture maker. And I put a few pictures up here to show you how she designs in 3D on the computer. That's the digital model. And then here's a quarter scale version of the piece that she prints out, cuts, using the digital fab equipment so she can look at it and handle it and make sense of it. Then here's one cut in MDF, which is a cheap, basically, print, so she can look and see if she likes it. And finally, she cuts it in the good stuff. You can see that continuum of digital fabrication. She markets her stuff to the world through systems like Etsy, representing the way in which people are becoming increasingly interested in having custom-made, handmade, well-crafted kinds of things. We're never going to get away from needing mass-produced stuff. But as a culture, we have a growing appreciation and a growing interest in wanting things made that we can really relate to, too. And that's what Brooke is up to. The interesting thing is she's also active in her own community. She has turned her shop into a technology incubator that other people are able to use, so that she trains, she shares, and she essentially bootstraps people up into this kind of stuff. Jeffrey and Jillian run a business called Because We Can. And what they really mean is because we can do it with digital fabrication. They do architectural interiors around the Bay Area, have become very popular with really creative interiors that they do, digital fabbed all the way along. They're also great proponents of the lifestyle aspect of jumping into digital fabrication as a small, craft, artisan kind of thing and making it your life. All of the people that I've showed you, or just about all of them, are participants in a network that we've created for digital fabricators. It's called 100K Garages, 100,000 Garages, 100kgarages.com. And the network serves the function of pulling together designers and fabbers for collaborative activity. There are resources there for them. But as importantly, the 100K Garages website is an outward-facing website where anybody who wants to get something made can go to find help with design and fabrication. You want a headboard made with a spaceship for your kid's bed? Go to 100K Garages. You can either get a tool there to help you design it, or you can find a designer to help you design it. And then you'll be able to find a fabricator, one of the many hundreds of fabricators now all around the US. You can find one near you who will actually cut the thing out, and you'll be able to go pick it up and put it above your kid's bed. It works kind of like this. You got something you want to design. You do it yourself with resources there, or find a designer. You and the designer connect with that local fabber. He cuts the parts. You accept delivery and get something that's really just the way you want it. So let me give you one example of how this can really work in action. This is Ann Filson and Gary Rohrbacher, who are architects and also furniture designers in Kentucky. They were contracted by MakerBot, one of the 3D printer companies, to develop an interior for their new office headquarters in New York. This interior involves something like 37 separate pieces of furniture that went in a number of rooms, entrance halls, reception areas, meeting rooms, and so on. They then located a fabber in the system on the East Coast named Bill Young. And I'll show you, this is Bill at work, time lapse. He's using two ShopBots here and digitally fabricating parts for the AtFab's furniture for the MakerBot headquarters, which you'll see in just a second, some of it being assembled there. You get the idea of the complexity of the parts coming off the tools, how they all fit together. And this is some of the pretty neat looking stuff that that turned out to be. That's how it all works. The bottom line is that small entrepreneurs in your communities using digital fabrication equipment can now do nice, right-sized manufacturing that is well-paying and supports attractive lifestyles. And they can do it in a way that provides the goods of everyday life to the community, or they can market to the world by developing specialty items that are sold in the long tail of the internet, or that that fit into the global sharing of parts and interfacing together complex parts for assemblies of one sort or another as they collaborate with each other in the global marketplace for making more complex things. All of this can happen in our communities. And I encourage you to think about encouraging these small-time entrepreneurs, manufacturing entrepreneurs, in every way you can in your communities, with incubators, with workspace, with manufacturing incubators, with encouragement and recognition. These new digital blacksmiths, these watchmakers to the world who are using the new digital equipment, these can be the people who will be the heroes of our manufacturing future. And we can help them here right now. I would just leave you for anybody that wants references. Those are some of the people I talked to.